Okay, we have reached the last practice problem for the final exam. I hope you're learning a lot as we go through this. That is the goal, is to kind of, combine what we know with some new knowledge which we're building through these exercises. There's quite a bit of familiar territory here with this statistical modeling, as we worked with this in our last unit of the class, but we're going to add some interesting twists to this. We're going to make the function a bit more dynamic, right? This has been a huge theme of the class, is building programs that are reusable and dynamic, meaning they can take in different inputs and perform the operations appropriately with that different information. So of course we have a pandas data frame as our first function input, but then we're going to be able to select what we want the feature variables to be. In other words, what collection of variables do we want to use to try to predict some target variable, and we also have the option of choosing what that target variable is as well. We have worked with the stats models library before, and we know that in order to use that library, we have to kind of set up a string version of the regression formula. Okay, so our first task is going to be to combine the feature variables in a way that will build the formula that is compatible with the stats models library. So you can call this whatever you want. I'll call it features combined. And I'll set that equal to, we're going to join the variables together with a plus. Okay, I'm going to also add some space to make it easier to see. We've used the join method way back in the beginning of the class, so we can use the join method here and say, well, what are we joining together? Okay, well, when we used the join method, we used it on a list of strings, okay? And we're going to do the same. Okay, so we're going to be joining together these feature variables so that we can then start to build the equation. So because it is a list, we can input that for the join method. Okay, I don't want to get too far, so let's say features, let's just print this to understand what we're working with. Okay, and I'm going to set up a new test case because the existing test case is somewhat involved. So let's see if I can get that to work. Okay, so this is what we have so far. Here's our feature variables, and they are in the format that will allow for use of the statistical modeling library. Okay, from here, we can construct the formula for regression just by adding together some strings, right? We can add strings together to create one longer string. So I'll say this is going to be the formula. Let's set that equal to our now third function parameter, which is our target variable. Okay, so we'll say target variable. And what do we need here? So we need plus. Okay, notice that the target variable example is grade. So that is a string. So I'm going to add that string to this string that I know is part of the formula because we've seen that before. And so we want to model the target variable as a function of the feature variables, which we've already created as features combined. Let me get a little space here. All right, great. Let's print that because I want to see what we have. Oh, no, I want to print formula. Let's see. Okay, here's our formula. And this looks just like what we are used to seeing when we use the stats models library in our unit 9 and in our assignment 9. So this is now ready to go, and we can now run the model. Now I'm going to be a little fussy here and do that, like it better. I don't know why I had to do that. Anyway, moving on. Let's build the model. Okay, so we could look this up on previous assignments. I'm going to help remind us how to do this. So let's set the model. You can call it what you want. This is my choice. Equal to stats models formula. That's the module that holds the ordinary least squares method, which is the most common method of regression analysis. First argument is the formula, which we have used the same variable name. So formula, and data is the data frame. That's our first function parameter. So data equals df. And then what do we usually do with that? We run a fit, use the fit method. Okay. All right, so that's going to do all that stuff. We build the model and it's going to calculate all of that regression output, the R squared value, the F statistic, the probability of the F statistic, which tells us if the model is statistically significant, and all of the coefficients in their p-values. So what we want to return is that model. So we return the model. And I need to get rid of these extra print statements that I used for development, because now the function is complete and it should return the model. I also am going to delete my extra test case and use the one that is already pre-built. Now you can see there's a whole bunch of code here. Let me explain what's happening in the code. First, we set up the feature variables, the target variable. Then we use the function, and we know that outputs the model. From that, we are going to access some information from those results. Okay, so the results are the model. Results, I'm going to access the R squared value, round that. I'm going to access the F p-value, which tells us if the model is statistically significant. I'm going to format that output so it's more readable. I'm going to access the parameters and their p-values. So the coefficients are those values in the model that quantify the nature of the relationship between the target variable and each predictor variable. Okay, then we have some formatting here. There's no code that you have to fill in this portion. It's just to output some results. Okay. So we can see pretty nicely the results that we've gotten. We have an R squared value of 0.81, and then we can take a look at the individual coefficients and their p-values to see which ones are statistically a p-value less than 0.05 is generally considered statistically significant. So, we can start to make some conclusions. So the grades, right? A person's grade could be expected to decrease by 4.21 for each absence. And so that's a numerical variable, but extracurricular participation was a categorical variable. So we could say that when somebody participates in extracurricular activities, they can expect an increase in their grade of 16.85 points. Okay, so that's some output from the statistical modeling exercise. And just want to point out that you could rerun the regression model with different inputs. You could select different variables. Why don't we actually do that? Let's copy all this and build a new one. Like normally what you would do is you would say, okay, well, let's just keep the variables that are statistically significant. So it looks like the math, participating in math class is not a statistically significant factor. And hours studied, I mean, people would be happy to see that. Hours studied was not statistically significant. It says a p-value of 0.99. And here we get a reduced model. The coefficients will change a little bit. Sometimes the p-values change as well when you run a different model. And the R squared did not change very much at all. So actually increased because we have fewer variables in the model. So there's less of a penalty in the adjusted R squared value. Okay, so that covers our last practice problem to help with the last problem on the final exam. So let me conclude by just saying what this exam is all about, right? This is all about customizing business solutions. And I think we've achieved that throughout our class. We've worked really hard to develop this notion of building programs that are reusable and dynamic and allow us to input different things. So we've tried to do that with these exercises to show how we can combine the libraries with our Python programming knowledge to build really powerful solutions. So thanks everybody, and I hope that was helpful for you.